Welcome to the webinar, everybody. We're going to be talking about remote critical power for the digital oil field. This is a joint webinar between JCE Energy and Morningstar, and it features off-grid solar power applications and case studies. Let's go ahead to the next slide that lists the handouts that you can download from the handout section of your GoToWebinar console. So we've attached a copy of today's presentation, also an application brief and the solar powered industrial systems guide, as well as links to case studies. So you want to go ahead and download that right now, or download them right now. I should also mention that we're going to be recording this broadcast, and you will receive an email tomorrow with a link to the recording. And as a special thanks, we're going to choose an attendee at the end of the webinar who will receive a free SunSaver charge controller. We'll also conduct a Q&A session after the giveaway. So please, during this webinar, feel free to text any questions that you might have in the questions or chat section of your interface, and we'll address them at the end. All right, so with that said, let's introduce the two presenters that you'll hear from today. We have Brad Burwald from Morningstar and Marco Geza from JCE Energy. And now, Brad, I'm going to hand off to you so you can take yourself off mute and start things off with a poll question for the audience.
Okay, great. Thanks very much, Mark. And again, very happy to be here, Marco and JCE, and being able to participate in presentation to everyone today. So with that, we'll be covering a lot of things, but we wanted to get things started off with a poll question. So you can see it on the slide there, and I'll just chat about it briefly. We're asking, how do you prefer to access power system operational data from a remote site? So that if you have remote data access or have other means, we wanted to find out about that. And the answers are basically, we don't monitor power remotely. If the system has problems, we investigate it. We use the solar power system vendor's data service, such as a controller or an energy portal from the solar product. The data can be integrated into a SCADA system using an API or possibly a PLC or HMI that is at the site, can collect the data and show it through the SCADA interface. Or there's a possibility of adding a third-party monitoring system as well. So let me go ahead, now that I've presented that, I will launch the poll. And if everyone could, in the audience, select an answer that best fits your use case for accessing power system data from a remote site. I'll keep this open for a few minutes. So please make your selection, and then we'll take a look at the results. And this info is good because it gives us an idea of what customers are doing generally at their sites for power management system information, and also everyone in the audience can see what others are doing as well. Okay, so please make your selection now. I'll give it just another minute, and then I'll close that and present the results to everyone. Okay, if everyone has made your final selection, I will go ahead and close things out, and we'll see what we learned. Okay. And the results are, let's see, it looks like only 13% are not doing any power monitoring. 34% use the solar power systems provider. Not surprisingly, the leading answer is 38% are integrating it into the SCADA system. So as you know, with a lot of our products, we use Modbus protocol, both RTU serial as well as IP, and I'm sure there's many other products that support that. And then lastly, it looks like 16% are using a third-party monitoring system, which could be a data logger and some other kind of shunt and measurement information to collect that data. Okay, very good to know that. So back to the main presentation. And with that, I will now hand over the first slide to Marco. Thank you, Marco.
Okay, thank you, Brad. Thank you, Brad. Good afternoon or good morning to everybody. My name is Marco, and I'm a General Manager for JCE Energy. I would like to spend a couple of slides introducing who is JCE Energy and how we cooperate with Morningstar. JCE Energy is a branch of JCE Group, which is specialized in off-grid renewable technologies to be used for off-grid power systems suitable for safe area, extreme, and hazardous area. The company has been established in 1998, Our main office is in Aberdeen and another one in Plymouth in UK. And what we provide to our client is a overall solution from design to the installation regarding off-grid power system in remote locations such as oil and gas, onshore, offshore, locations where the grid connection is pretty impossible. And also, again, our solutions are every time a turnkey solution. So let's go to the next slide now to see a couple of products that we can offer. So next slide, please. At JCE Energy, we can offer a variety of products from solar panels rated at ATEX zone 1 or zone 2, power from 135 to 365 watts. Then we can offer battery systems from 5 amps hour to 2000 amps hours, 24 or 48 volts, charge controllers where we work with Morningstar, battery charging systems, wind turbines, also for safe area, industrial, and also ATEX zone 2 wind turbines. And at the bottom, you can see an overview regarding the standards where our products are complying with. So let's go to the next slide now regarding our capabilities. Here, there is a very brief overview regarding what we can offer to our clients. We start from the engineering and development. So we start with an energy audit and system energy design. Then our engineers are capable of providing a software engineering service as well, developing PLC, HMI, SCADA systems, and the integration to an existing SCADA system as well. Then we go to the manufacturing and testing, where we can manufacture in our workshop in Aberdeen and in Plymouth products certified for either zone 1 or zone 2. Again, solar power systems, so solar panels, batteries, distribution boards, and so on. Then we go to the installation and commissioning. Our personnel, which is qualified with complex qualifications and also all the relevant certification, can help our clients to install and commission the products on their sites. So let's go to the next slide regarding a couple of small examples which give a very brief overview. We would like to spend a couple of words regarding the JCE and the Morningstar cooperation. The cooperation is a very long time cooperation, and with Morningstar we have already developed hundreds of projects all around the world. JCE with Morningstar is an approved system integrator for their products. We are also a distribution partners for the products made by Morningstar. And also we can provide to our client a technical support to any kind of problem that they encounter with the solar charge controllers and also their products. We act as well as a facilitator regarding the Morningstar products to enter and penetrate a little bit more the ATEX and IECEx market. So let's go to the next slide. Okay, in this slide, we would like to give you an overview regarding the different locations where JCE and Morningstar have cooperated together so far. As you can see, there are 4 pictures, one taken from a project that we have done in Indonesia, the other one a project in Kuwait, another one in Scotland, and another one in Denmark. As you can imagine, all these 3 locations, they are presenting challenges in terms of temperature, weather conditions, different standards. The standards that we are working with in Denmark are completely different with the standards that you are working with in Kuwait. But also, and I would like to stress a little bit more with this parameter, is the solar irradiation. As you can see in these slides, in these pictures, we have 4 different solar power systems, but I would like to show in the next slide how much a power system is influenced by the solar irradiance. So if we can go to the next slide. Okay, here we are presenting a classical example, which is quite frequently asked by our clients, which is powering up 20 watts of continuous power, which could be, for example, a sensor or maybe 1 or 2 sensors, providing 4 days of battery autonomy and 1 day system backup recharge time. Here we have presented 2 different scenarios, the same system working in Southeast of Asia and the same system working in the North Sea. The Southeast is in the left, North Sea is in the right. In blue, you have the level of solar irradiation at the different months of the year. As you can see, the 2 scenarios are completely different. So especially for the North Sea during January and December, we have basically just almost 10 hours of sun per day. So you can see from here how much this influences the sizing of the solar panels. On the left of the same system, as you can see, just requires 2 solar panels, in this case 2 solar panels, 365 watts each. In the North Sea, the same system requires 8 solar panels of the same rating. So basically 4 times more solar panels. This is very important to be understood because many times our clients, they don't realize the cost associated with the system and why sometimes, especially in the North Sea, the costs are rising. Maybe looks a little bit too much, but there is a reason behind that, and one of the reasons is that one. So let's go. Now I give the word back to Brother regarding Morningstar.
Thanks very much, Marco. I appreciate that. And yeah, now I'd like to talk a little bit about Morningstar's products, just an overview of the company. And we will give several other examples of how our products are used together between the 2 of us. First of all, over 4 million products have been sold by Morningstar, which was incorporated in 1993. And we sell around the world in over 100 countries, typically focusing on mission critical applications, such as those we've been talking about, as well as others in industrial applications, telecom, security, and lighting. And we like to think of ourselves as the charging experts. We have a very diverse product line, each of these with different power ratings, different industry certifications, and sometimes very specific application-centric features that are used, such as lighting control or certain types of environmental protections. We also do participate in commercial solar, residential and rural electrification, as well as the mobile and marine markets. One of the projects of note that we did for the country of Peru was what we believe is the largest residential off-grid project that has occurred, and that was regarding 200,000 homes that were upgraded with DC energy boxes to power home-based loads such as cell phone charging and simple LED lighting, as well as 3,000 community centers. And all in all, between those number of systems, over 1 million people were impacted and provided additional energy supply. Okay. Solar is a well-established application for oil and gas because of the highly efficient nature, the fact that the energy is delivered by the sun to the site, and solar panels generate native DC power, which is often used to power DC loads at the site. They've really become a top energy usage application for the oil and gas industry. They have an extremely long operating life, sometimes of several decades, and warranties sometimes to match. The power data, as was mentioned earlier, can integrate into SCADA systems. Native Modbus capabilities, or sometimes SNMP, can be used to collect data from the power system. And they are typically operated at 12, 24, or 48 volts DC. And they're also very beneficial when used in a hybrid application. And by that, I mean solar for its daily provisioning of energy, but also in combination with thermoelectric generators, fuel cells, or other types of fuel generation. Even wind at times can be used in combination. So it's also one of the most reliable and proven in the industry. And you can see here with a quick overview of other generation technologies that are used on site. It has one of the lowest OPEX of any product used for power generation. Typically no moving parts because it's completely passive, no required maintenance or teardowns or rebuilds. Fueling is not required. As I said, the sun shines every day. And it also achieves a bit of a green oil field objective as well, because you're looking at fossil fuel sourcing, but using renewable energies to provide a lot of the power. And it's also very ideal for extreme conditions because of the reliable nature of the solar modules and the power electronics having quite broad operating ranges and are built for, resiliency in these types of harsh climates and temperatures. So the typical loads or applications that are actually being powered at these sites can vary dramatically, and there's a variety of them that are actually covered in the industry we're talking about today. So at the most basic level, some of our solar products, the SunSaver MPPT featured there on the left, can provide power for small DC loads. They're small but highly important because they're measuring, very valuable assets and critical safety and equipment operating conditions. RTUs, PLCs, various wireless I/O systems that are measuring data, pressure and flow levels, often at the pipelines. You can get into some higher power loads such as actuators or solenoids that are basically turning off or opening valves. And then lastly, security cameras is a very growing load because of its ability to not only provide security and see what's happening at the site, but detect anomalous site conditions, such as something that could be dangerous. In larger applications, the products can scale up considerably and provide much more power, and then you can provide continuous power for 24/7 operated cathodic protection systems, injection of basically methanol in systems to keep them flowing in cold conditions, pumps and motor drives, as well as UPS and backup power systems, even for those that are also powered by the grid. Okay, so with that, I will hand this back to Marco to cover some solar applications in detail. Marco?
Okay, thank you very much, Brad. In this section, we would like to spend 2 or 3 slides regarding the most common applications regarding off-grid power systems, especially in the oil and gas, so ATEX Zone 1 and Zone 2, but also in industrial applications. Not too much in detail because later on we will present 2 case studies more in detail. Here you can see the most classical example of off-grid power system to be used in offshore power facilities. Here is an oil platform in the Danish sector of the North Sea, where we have provided a system to supply power for navets and foghorns, communication systems, bird deterrent, and cathodic protection. And also here is demonstrated the importance of having a very robust and a reliable product, and also very well sized in order to give power to these critical loads, which are absolutely very important for this kind of facility. As an example, you can see in the center of the page one of our charge controllers that we have developed for this project, and here you can see one charge controller provided by Morningstar. One of the other classical examples could be also onshore, and to do that we need to go to the next slide. Okay, this slide represents another example, not offshore but an onshore project that we have done in Kuwait, in the Middle East. The aim of this project was to provide power for pressure relief valves, pumps, cathodic protection again. So it's very important to understand, as you can see from this kind of projects, the temperatures that is anyway is a subject that will be touched a little bit more later on. And also the difficulties of designing a system in such an environment like that one. We can also present in the next slide an example of a system that we have developed for the industrial for an industrial application. So if we can go to the next slide. Okay, here we are in a mining and quarry application. Here the client have asked for a complete solution, completely transportable, and equipped with cameras to operate the telemetry system within the quarry. All this system has been designed to be integrated in their own system because the cameras are equipped with a facility which detects the nameplate of the lorries which are running inside the quarry. Without going into many details of on this case study, the importance is that this case study demonstrates also the application in a market which is not IECEx or ATEX. But here we are also using an industrial and heavy duty application. As you can imagine, working inside the mining and quarry requires heavy duty products. And this is a very good demonstration for this kind of concept. So I give to Brad back again the word regarding their product.
Okay, thanks very much, Marco. Yeah, all those sites are incredibly interesting, including obviously the platforms. You know, reliability is really key there because it's not something you can easily visit without some major vehicles and equipment. Yeah, so to talk about the charge controller in a little more detail, it has a critical role in the system because it's in a key position between the PV modules and the battery. So all the power coming in, the battery management, and then of course the power flowing out to the loads can be controlled and monitored and measured by the charge controller. And its main job is to convert the PV panel voltages, which are DC, but need a little bit of regulation, to the proper output voltage for the battery, to put it through those 4 charging stages and to make sure that the load is given the proper voltage as well. It prevents overcharging by using that 4-stage charging algorithm. It can provide load disconnect in case the battery is discharged too deeply. It can temporarily disconnect that to preserve the life of batteries so that they last for the many years that they're typically designed to last for. And the right controller can also extend battery life. As you've seen in some of these photos, there's some very extreme applications and weather at play at these sites. And cold temperatures generally can degrade batteries, and charging has to be higher to compensate. And the same goes in high temperatures as well. And really, if you don't have the right controller, your investment in that large PV array and a very expensive battery bank can possibly not give you, the results you're looking for if the batteries are not maintained, because the whole system has to work together, and the charge controller really is what drives a lot of the longevity of the battery. Proper settings and of course the right product choice. You can see on the side here a lot of DC loads that can be provided. Power directly from the batteries are a lot of the previous industrial and automation loads that I talked about in the previous slides. It should be noted that you can also provide power for AC loads. So if you're looking for 120 or 230 volt sine wave output power, similar to the grid, that can also be provided by using an inverter. And generally, these have a little bit more power draw, but can make it easier to find compatible equipment, especially motors, which generally prefer AC when possible. Remote monitoring is critical with power management, because if you lose a load or your equipment or the information or SCADA data is no longer being relayed back to where it's being monitored and you don't know why, it's good to have visibility of what's happening with the power system. Is the array providing proper output, close to its rated power levels? Is the battery healthy? Is your load being sustained day after day? Is the load being powered, during inclement weather? Batteries are designed for several days of autonomy, but there are times when the weather's not so great, especially depending on, the regions in the North Sea, as Marco had said, where you need a lot more solar. So all this can be monitored remotely. And generally the products can provide serial to PLC or even IP-based over Ethernet Modbus data. And then from there, it can be measured and monitored by cloud SCADA systems. There's a simple web page. And also we've recently supported some telecom standards such as SNMP, which allows it to integrate more easily into network management systems that may be also monitoring data and modems, routers and switches and other types of equipment. So there's a lot of options, but supporting third-party protocols and integration into systems is really what the products are designed to do best. So now changing topics to the HazLoc certifications. These are the various NRTLs and lab certifications for hazardous location use that have been applied to the products. So you'll see some familiar logos here, Intertek or ETL, which generally provides listings to the UL and North American CSA standards for the United States and Canada. Also IECEx, which is the the similar HazLocation rating that covers much of the rest of the world, namely in Asia and the East. And then the ATEX certification, which is a little more focused on Europe and specifically in the UK. But all three of these certifications and marks are now available on a variety of products from Morningstar. And I'll talk about those in a little more detail here. So again, here's a summary. You can see that Underwriters Laboratory provides a lot of these standards and ETL tests to them, as well as the Canadian Standards Association. So all the products that meet those requirements for oil, gas, and HazLoc use in North America. And then IECEx covering much of the international, and ATEX also for the European Union. And they have some obviously kind of provide the same intended purpose in terms of the regions they can be used in, but what we'll talk about on the next slide is a little bit some of the differences in the terminology that is used there. So what we're talking about specifically when we have our products rated for Class 1, Division 2, is that these are locations in the sites where the equipment is being used that are not hazardous continuously 24/7, but that there is a probability that they could become hazardous during abnormal conditions. So that means if you are on a pipeline or near a well, everything is operating normally, there's not an explosive environment. But if there were something to occur, explosive materials or gases may be present, and the products need to be suitably rated to not cause any type of adverse incident, namely an explosion. So with that being said, Class 1 covers gas and vapors. And then as you can see on the right there, not likely under normal conditions, but which could occur, is classified as Division 2 for North America, or that same area is called Zone 2 under the EU and international standards. So we have tested to all of those. So that's generally the type of environment. The others where you have continuously hazardous under normal operation, those would typically be a Division 1 and a lower rating, and products could be more suitably rated to those with additional equipment. So when you're looking at the HazLocation sites, again, gas, vapors, liquids can cover dust and fibers. We're mainly talking about, gaseous substances in this case. And if you have an ignition source, that's why the products have to undergo extreme testing to make sure that there are no relays or switches that can arc, or something that would cause excessive heat at the surface of the controller in a normal operation to provide that ignition source, okay? And there's three ways you can prevent that from causing that explosion with those ignition sources. You can either isolate the explosive substance completely, such as completely enclosing it or enclosing the product. You can put it into an explosion-proof housing, which would, wouldn't prevent it, but would contain it if there was an explosion. Can be done, a bit difficult. And then lastly, intrinsic safety, which is making sure that there is no possibility of a spark. And that's mainly where these products are designed to comply. So when you see these certs, it's very important to know exactly what class and division you have. And that's why the products go through a very specific marking process, not only to show that the product is suitably rated, but what those specifics are. And in this case, the Class 1 Division 2 mark is on the product. And you can even see that there's classifications for the gaseous groups A through D, which cover various types of gases on the right, because each of them has different behaviors and it has to be real clear what this product is rated for. And it also includes a temperature classification, in this case T5, which means it allows for operation close to 100 C. Okay, with that, I will hand this back to Marco. Thank you.
Okay, thank you very much, Brad. In this slide, we would like to spend a couple of words regarding what does this mean in practice. So when you design an off-grid power system. As you can imagine, there are many challenges regarding the design of a off-grid power system, especially in oil and gas, ATEX Zone 1 or Zone 2 rated. The challenges are coming from, first of all, from the standards, secondly, from the rating of the equipment, and thirdly, from the certification. Here we have summarized two of the key parameters which are leading to the design of the system. Of course, there are many other more parameters, and of course, a webinar is not probably sufficient to list them all, but the heat dissipation and the space constraints inside the enclosure are the key parameters which dictate the design of the system, especially when you are using solar charge controllers. For example, the heat dissipation, the electrical apparatus which needs to be installed inside an enclosure, they need to be compliant with the heat dissipation maximum inside of this enclosure. Just to give you an example, our EJB60 enclosure accepts electrical apparatus with no more than 240 watts of heat dissipation inside this enclosure. So even if you can install theoretically 2 or 3 or 4 solar charge controllers, maybe you must install just 2 and maybe adding another enclosure. The other parameter is a space constraint inside the enclosure, which comes again from the certification of the enclosure, which obliges that inside the space of the enclosure must not be populated more than the 80% of the area available inside the enclosure. From just these two basic parameters, you can also understand how much an ATEX Zone 1 and Zone 2 system becomes big and also becomes expensive. Of course, again, there is a reason behind that, and one of the main reasons are listed here, so heat dissipation and space constraint. So I give back again the word to Brad regarding the Morningstar product in the oil and gas market.
Okay, thanks very much. Yeah, and I appreciate that slide very much because it really shows, what's critical with these designs is making sure the space is correct. And we actually, since we design for industrial applications, we have a lot of engineering data and heat dissipation data on the products. We push to have very high efficiency, and that only delivers more power to the battery, which means there's more power to use, but less waste heat, which keeps the heat down. And providing these wattage output ratings for this type of enclosure design is something that we're committed to on our support, when working with integrators such as JCE, so that they have this information and they can make the best decision with system design. So moving on, then I'd like to talk a little bit more about products specifically in name and in detail. And you can see a good example here of the breadth of our Hazardous located product line. Across the top are ProStar MPPTs and ProStar PWMs with and without meter display, our SunSaver MPPT, and our SunSaver PWM. And these two types of controllers, whether you need just simple PWM control or maximum power point tracking on the product, all are suitably rated for these locations. And you can see below there, all of those families have ATEX, IECEx, as well as the ETL listing for HazLoc. We do have a unique product called the Sunkeeper, which is actually a waterproof design that connects to the junction box for very small loads, and that all has an ETL rating as well. And you can see below the various markings and the specific terminology that is used for these different classifications on the products. So a little bit about the products in detail here, just to go over a few of the features. And again, all these we're talking about here have HazLoc. Our SunSaver MPPT, it is a maximum power point tracker, although quite small and compact to minimize space taken up on the back panel. And it's a high frequency design, which is what lends itself to the small size, but that also means we have very good control over power. And it has features like short circuit protection, reverse polarity, self-diagnostics built in, all of which can be relayed over the SCADA data that I talked about before. Really industrial rated terminals. And we use, of course, all passive cooling, meaning there's no fans. And we use extruded or even sometimes cast aluminum heat sinks in these products to make sure that they get the heat out effectively and, as I said, without the use of moving air. because many times these cabinets are completely sealed. And this product does communicate with Modbus, and it can be converted to SNMP as well. That's definitely a favorite in a lot of small applications. Moving up into larger power, our ProStar PWM and MPPT products, both in the ProStar family, provide a lot more capabilities. Still 12-24 volts, but also much greater output current, as well as higher input voltage for the solar module for a variety of applications, and optional meter displays that allow quick status as well as fine detailed editing of battery set points and other types of controls. So they have the same ratings. Again, a Lexan polycarbonate case that makes them extremely rugged, as well as the self-diagnostics that I talked about. All of Morningstar's MPPT controllers use our specially designed tracking algorithm called TrackStar that just provides overall a lot of speed and efficiency. And where it really comes in uniquely handy is when you get applications such as moving vehicles or trailers where the array might change quite often, and you want to make sure it's very efficiently tracked. Looking inside the controller, we often like to talk about the design inside the chassis, because the circuit board is just as important as the case as well in providing long life. So you can see we have a unique three-phase design there, not three-phase AC, but 3 individual circuit phases for the controller, and that allows it to have much better efficiency overall and run cool. We have the ability to support Modbus again, of course, in this product, and some of our more unique features, such as our use of direct FETs and high-speed ARM processing for all of our products. That gives them a lot more capabilities, power electronics control, and sort of future-proofs them with firmware updates and new features that can be offered in the future. Now, our TriStar family of products here, MPPT and PWM, these not have specifically marked listings, but are still used extensively in these types of applications. And you can see there an EXD flame-proof housing where the controllers have been integrated, and then they are able to provide up to 3 kilowatts of continuous power to the battery, and in many cases, solar module sizing capabilities well beyond that, as many as say 4 kilowatts, if you want to provide extra redundancy and maximize delivered power. So these products all support 12, 24, as well as 48 volt applications. That's a typical favorite of a lot of cathodic protection, but still the same hallmark design traits, such as the fanless design and the very high efficiency as well. And looking inside of the TriStar PPT, again, some very unique designs, such as our passive spring FET system, which ensures cooling, no fan use, and also that 3 stage circuit design that allows it to, I kind of relate it to like a gearbox. Stages 1, 2, and 3 can turn on or off, just like shifting gears in a vehicle, as you need more or less power, and that keeps the efficiency, or in a car, RPM consistent, which is what really provides high reliability and maximum power output. Okay, so moving on, this brings us to our next poll question. So I will go ahead and launch, let me just give a brief overview, and then I'll launch the poll and everyone can give their input. It's very much appreciated. So the impact of new HazLoc ratings. Okay, so a lot of these ratings have more recently been added to these products, and our portfolio has broadened to include higher power, data-enabled products, and not only PWM, which was typically used there before, but also MPPT controllers, several of them in these HazLoc rated applications. And what we'd like to find out is, what is your view of the measured impact on having these new higher power products available for HazLoc use? Okay, so I will go ahead and launch the poll so that all the audience members can go ahead and make a selection. So please, if you're watching, let us know what you think of these additional systems. Again, greater than 20 amps, now up to 40 amps of charging into a battery at 12 or 24 volts, and the ability to have meter displays, full SCADA Modbus data is now available on the products that have a HazLoc and can be put within the zone and be measured data from, as well as the ability to use modules that have higher ratings and get more delivered power with MPPT, now available in HazLoc. Okay, so it looks like things have quieted down there, so I will go ahead and give you a few more seconds, and then I'm going to close the poll and we'll display the results. Okay, So the poll is closed, and I'll go ahead and display that. And it looks like good news, a very large impact. So we're hoping that that provides a lot of additional design options for those that are using Morningstar controllers and doing integration that are on the call today. Many more say as well, 25%. So I would say over half say it's a medium to high impact in terms of affecting their business and designs. And then lastly, a small impact, a very small number, 32% said not sure. So hopefully with more information on these products and seeing some of the benefits of adding data or MPPT to these systems, we will be able to see what kind of impact they'll have in the future as they are communicated. Okay, just one moment. I'm going to get back on track here with my let's see here. I will keep the presentation going. I believe that Marco has some connectivity issues. So what I will do is continue through the presentation and give him a few minutes to rejoin the presentation, possibly having some internet troubles. So let me go ahead and proceed with the slideshow, and we will do what we can. Just one moment. Okay, we'll give Marco just a couple of minutes to rejoin. I will.
Yeah,
Okay.
Hello.
Okay. Hello, Marco.
Hello. Sorry, we got a small problem regarding the internet connection. Now,
no problem.
Okay, thank you.
Okay. Yeah,
thank you for the patience.
Yeah, we just went through and we just finished the last poll. So yeah, these things happen in the internet world. So we've just arrived at the case studies, actually.
Okay.
So if you're ready to join, I will hand it back to you and take us to the first slide of the case studies, and then you can take it away. Thank you.
Okay, thank you very much, brother. In this section, we would like to give you an overview regarding two different case studies. But before doing that, we have prepared this diagram, which describes in general terms what JCE can offer to their clients in terms of size of the systems. On the left, you have our smallest unit, which is called the ePod, which is a box capable of powering 10 watts, for example, a sensor. Then you go a little bit up with our most famous product, which is the solar power pod. Equipped with a single solar panel or a dual solar panel. This unit is completely capable of providing power from 10 watts to 200 watts. So in this case, multiple sensors, maybe also data logger if you want, and also telemetry systems. Then we go a little bit higher in size, and then we have complete systems with multiple solar panels, even 10, 20, 100 solar panels, or 200 solar panels, capable of providing power from 200 watts to 2 kilowatts, or even more if you want. And then the loads in this case can be telecommunications, nav aids, RTU, valves, cathodic protection, basically an entire offshore facility or onshore facility. So let's go to the next slide with the first case study. The case study number one is related to a project that we have developed in the Java Sea in Indonesia for a local client. These are two remote wellhead solar power systems. The installed capacity is 16 kilowatts in total. The load requirement from the client was 1.6 kilowatts continuous 24 hours per day, 365 days per year. The battery autonomy required was 4 days because due to the IALA regulations. And it's very interesting to say that we have used in this case NiCad batteries. And I must say that the charge controller provided by from Morningstar was extremely good in this kind of application because this gave us the ability to modify a little bit the charging parameters to match the charging parameters for the NiCad batteries, which are pretty particular, to be honest. So continuing, the voltage required by the system was from 24 volts to 30 and 400 volts AC. And the peculiarity of this system is that we have developed a unique system, which is called the battery monitoring system, BMS. Every single cell used in this project has been monitored and the data sent constantly to the client onshore, so that the client can also see potential failures of the system. So let's go to the next slide, please. Here we have the scope of work regarding our scope of work with the client. We have started with the field study, design engineering. We have manufactured everything here in our workshop in Aberdeen. We have assembled all the system. Then we have performed all the FAT and SAT tests. And then we provided the commissioning support to the client. Of course, in the meantime, we have helped the client for the interconnection cables calculation, which was extremely complicated in this case. With this system, the application is used to power local instrumentation, telecommunication equipment, nav aids, process equipment such as pump, dosing pumps, etc., and also motors. So let's go to the next slide to see a couple of examples. Here you can see an overview of the different products which has been manufactured here in Aberdeen. At the bottom right, you can see the internal part of the battery. Again, you can see from this picture that the battery is made with single cells, and every single cell has been monitored using our unique developed BMS system. In the middle, you can see a series of solar charge controllers, MPPT60, provided by Morningstar, assembled on a testing bench on our laboratory just to test the algorithm to charge the battery correctly. The system has been manufactured completely to be suitable for zone 1, as you can see in the description in the top left. 150 solar panels has been manufactured. Batteries enclosure for 13,000 amps hour in total at 24 volts. Again, the battery monitoring systems, and also a couple of skids for distribution power within the facility. So let's go to the next slide. Here there is a case study number 2, which is a hybrid system which is powering an offshore facility in the Danish sector of the North Sea. Here the total installed capacity is 10 kilowatts, which is reached using the 3 kilowatt zone 2 wind turbine, the first zone 2 wind turbine in the market, plus the rest with zone 2 solar panels manufactured by JCE. The load requirement in this case was 800 watts, again continuous all around the days and all around the year. Battery autonomy required 4 days. The battery technology used is VRLA, and that's why we have used again the Morningstar charge controllers, because they allow you to control and charge properly also this kind of batteries. The voltage in this case has been required to be 24 volts regulated. And the interesting part of this job is the load management system, the LMS. The system is designed, there is a SCADA system designed to switch off the loads when the system detects critical state of charge of the battery. There is a list of loads, so the top priority, less priority, and the system is completely automatically capable of switching on and off the loads according to the battery state of charge. So let's go to the next slide. Here the scope of work again was from the detailed design, manufactured, system assembly, FAT and SAT test, installation support, and commissioning. The system, again, powered cathodic protection, telecoms, navigate, bird deterrent systems, fog horns, and also additional loads, which are pumps, sensors, alarms, data loggers, etc. So let's go to the next slide. Here you can see also for this project a couple of examples regarding different products specifically manufactured in our workshop. At the top right, you can see the Zone 2 3 kilowatts wind turbine, which is working, by the way, with a Morningstar SAS controller 60 amps. At the bottom right, an assembly incorporating 4 solar panels. We have used in total 4 of this assembly to inside the facility. In the center, in the bottom center, you see a battery. We have used 3 batteries, 1,415 amps hour each battery, 24 volts. And at the top, you can see an example of the SAS controller provided by Morningstar. So I completed my overview regarding the case study, and now I give the word back to Brad regarding their experiences in the United States.
Okay, great. Thanks, Marco. Yeah, it's great to see all these applications and how they come together. You know, significant amounts of power being used there. You know, even at 24 volts, and you know, also working with a lot of newer, longer-lasting, you know, battery chemistries such as NiCad and lithium have become really common for our products, because they're looking to push the storage to last longer and do more. So really interesting to see it actually in use in the market. A couple other applications here, I'll just touch on them briefly, not so much case studies, but just to show the diversity and different types of systems that get used. Our SunSaver product being one of the most popular and typical in these types of hazardous locations is often used for natural gas as well. And simple monitoring is really critical. You've got these handoff points or these small shelters that are built where there's some valves that are, you know, above ground, where there's control or transfer of assets, and they need measurement capabilities. So it doesn't take a lot of power, but the RTU's job is extremely important. So just a simple module such as the one on the roof there, just one of them, and a SunSaver 10 gets the job done. Another application here is a remote power system in South Texas. This is at an oil and gas site as well in the Eagle Ford shale site location, one that I've actually been able to visit myself to see some of this equipment installed. And it was a really big area of development for a lot of these applications. And these TriStars were used in these sites as well as SunSavers. So typically you'll see TriStars managing larger equipment and cabinets like the one that's on display there, such as driving you know, a PLC for a region. And then you'll see smaller feeder pipelines that distribute gas to something like a compressor station that will then actually distribute it across state. And we're typically running, yeah, RTUs and in some cases cathodic protection as well. And then lastly, here's a field automation system. These are some that are in Texas as well as in the state of Colorado. And again, pretty significant in size. You can see on the bottom right there that not only is the TriStar being used for the solar management, but as I explained earlier in the presentation, there's some AC power that's required as well. You know, possibly 110 volt AC to drive certain types of equipment loads. You can have a mixed DC and AC system as well, all provided with solar applications. And a big benefit here is, you know, of course, the ability for it to be located right on site with the equipment. Okay, and then this one specifically back to Marco to cover.
Okay, thank you, Brad. Here's another product that we have developed in the Middle East, in the middle of the desert, where you can imagine that the temperatures are reaching between 50 and 60 degrees Celsius. The unit has been designed to be completely transportable and also deployed very quickly from one site to another one. And has been used for injection chemicals in oil wells. So there are different oil wells in this area. They need to inject chemicals inside these oil wells, and they need a solution to cover without diesel generation, local diesel generation, all these wells. So as you can see, we have used massively the TriStar SAS controller which is, by the way, one of the we're using for the big project, as Brad said previously, this kind of task controller, because it's perfect for our application, especially also applications like that one. And the system designed for this application has been suitable for ATEX Zone 2. So as you can see, we have used our enclosures to build up the system. So I finished my speech here. So back again to Brad.
Okay, thanks, Marco, for those reviews. Yeah, it's great. You know, we often cover case studies a lot because people want to know where our products are being used in the many applications of solar, especially off grid. But you know, we appreciate collaborating with you on this presentation because we can hear it directly from you, the types of designs you're doing, where they're located, and the decisions that have to be made. So it's all real exciting. On that topic, solar for oil and gas is covered in many other case studies as well. You'll see the one with JCE Energy attached to the handouts in this presentation, as well as the webinar. And you can find many others available on Morningstar's case studies website. So there's the link as well, and you can get an example there of what else has been done. Further to that, Morningstar's Industrial Solar Guide, which is really a combination of applications on a specific topic, such as industrial only, and the many products that fit that application are covered in detail in this handy guide. So you'll find both some descriptive as well as specs and just kind of general overviews. And it's a very interesting read, one of the many excellent resources put together by Morningstar's marketing department. And then lastly, we also have a specific write-up that has been used in many websites, industry associations, and publications. That is Solar Powering the Digital Oil Field. Also a very good read about the needs of the digital oil field, you know, remote power, data collection, and where things have been in the past and where they're headed. Okay, and those are all available. So with that, I will come to the last slide, and we will talk about the giveaway of one of Morningstar's products, and I will hand the presentation back to Mark. Thanks, Mark.
Okay, thanks very much, Brad, and also Marco. Terrific presentation. And yes, as a special thanks for attending today, we are giving away a SunSaver controller to the lucky winner, and that random winner is Amanda L. So we will contact you, Amanda, about where we should ship this SunSaver to. So thanks very much for everyone for attending, and congratulations to Amanda. Terrific. With that, let's go to the Q&A session because we do have some questions that that came in, and interesting questions here. So let me just start off with, let's see, a question here coming in from Ahmad asks, hi, is the BMS system included, or does the BMS system include the function of temperature compensation? So I guess I can send that to Brad as well as Marco.
Yeah, I'd say I can comment on the temperature compensation in our products, but Marco, if you want to discuss the BMS, since that was your integration, that would be interesting.
So the BMS is a system which gathers data of the battery. The temperature compensation has been developed inside the charge controller. So the charge controller, and also when we have calculated the battery.
Okay. Yeah, in Morningstar's products, to take one example in a little more detail, when he spoke of the nickel cadmium batteries that were used, excellent battery technology known for their extremely long life. They have a slightly different cell voltage per cell than a lead acid battery, and definitely from lithium. So with those specifically, the temperature compensation, how much we charge higher or lower based on hot or cold temperatures, has to be slightly changed. And as he said during the presentation, that's custom, and the product can be specially programmed to allow that different battery chemistry to be supported, and that includes temp comp. It's generally a little more subdued. It's not as much of a compensation coefficient as required for lead acid, but that's what makes them, you know, quite resilient.
Okay, very good. Thanks for that question. I see another question from Ali coming in. The question is, in the case study number 2, it's actually a two-part question, does the installed capacity represent the installed solar panel, And what is the used LMS? Can you provide more details about that? So I believe this would be a question for Marco. I think he
Yes,
covered this.
the installed capacity includes both the solar panels and the wind turbine. The wind turbine is being rated at 3 kilowatts. Plus, we have built a series of, as you can see from the picture, skids equipped with 4 solar panels per skid to reach a total of 10 kilowatts.
Okay.
Have I answered
Anything?
the question? I hope so.
Well, I beg your pardon? The other part of that question, what is the used LMS, the used load management system?
Sorry again?
He also asked, what is the load management? What is the used load management system?
What is the used load management system? So in this case, we have developed a list of power supplies in this project, from the most important to the least important. The LMS system reads every time the parameters from the battery, determines the state of charge of the battery. For example, if at some point you reach 40% battery capacity and you don't need to go below the 20% of the battery capacity, then the LMS system knows that, for example, the cathodic protection can be switched off for a couple of hours just to leave the battery recharge back again to an acceptable level when the cathodic protection can be re-switched off back again. This is how is working the LMS system. Of course, there are many other more functionalities, of course, but this is also a brief overview regarding the LMS system.
Okay, very good. Thanks for that question and answer. Let's see, this question here coming in from Daryl. Let's see, he asks, is the spacing around the MPPT controller recommended in the operation manual necessary? I was under the assumption that it needed a few inches of clearance to dissipate heat properly, but some of those panel photos don't seem to follow that spec. Or let's see, I can't read this. Let me see if I can make that a little bigger.
I think I can address
Brad,
that.
you might be able to address that. I'm opening up the question.
Yeah. This kind of goes into the point I was making earlier in that discussing the enclosure cooling and spacing requirements is there's a lot to review and there's a lot of data. And we work really hard on this. It takes up a lot of our application support effort to work closely with customers because you really get the best outcome when we work together. So on 2 points, one, when Marco was covering a little bit of the spacing required there, I believe there are some specific hazardous location requirements in terms of the enclosure space. It can't be too densely packed and how much room is available. So that may be a local code, a HazLoc requirement, or maybe a design constraint of the system itself. Now, on the Morningstar controller side, in our operating manual, we do specify recommended spacing requirements for the product. And that's really just as a guideline in order to ensure that you're going to get proper cooling of the product and that it'll actually operate to its rated specifications. There is some variability with that. For instance, if you really are out of space, I think we want to see 6 inches above. We can actually do less space above if the product is derated slightly. That depends on the efficiency, the voltage, the ambient temperature, and how much of the product is being utilized. If it's at 100%, it's more challenging, but often these systems get derated to 50 or 75%, depending on a lot of this information. So bottom line, the spacing requirements, the recommendations, you can deviate from them, but it just requires a little more of a look at the power and possibly consulting with Morningstar application or engineering support, to get that go ahead. And we do that often with these types of integrations.
All right, very good. It probably depends on the location of the application as well, I would assume. What kind of climate?
Yeah, exactly. Temperature, heating, and sometimes the presence. There can be active cooling in addition to the systems, not in our products, but it may be added. That changes the game entirely.
Okay, here's a question for both of you. I guess we can start off with Brad. What is the lowest temperature your products operate at? So we can, I guess, pose that question to Brad, and then Marco, you might have additional information you might want to add to that question. So what is the lowest temperature your products or systems operate at?
We typically design the products to have a minimum operating temperature of -40°C. Okay, so we take that into account with all the components, especially capacitors and things that are a little more, intolerant of, extreme temperatures. We get them designed to actually be a higher rating than most indoor electronics, but -40 is the low end. The only thing that typically doesn't meet that is if you do have a meter display on some of our products. The meters typically, I think, are rated only to -20. They'll still work, just more slowly. They're not damaged per se. They just may not be as responsive if you're actually looking at the display, and that's because liquid crystal doesn't move too quickly to changes at -20. So, but yeah, it's -40, and of course, they self-heat a little bit in the enclosure, so that usually keeps them much higher when they're actually in operation.
Okay, and is there anything that you would like to add to that, Marco, for your systems? Anything that you've experienced?
Yes, for example, in the North Sea, we experience every time temperatures well below zero, so -10 and -20. So for the charge controllers, as Brad said, there are not any problems, of course, because they are rated to -40. Of course, the lowest temperatures become a challenge, especially for the batteries. But when we design the system, we incorporate the temperature compensation factors for the batteries. So we add an extra capacity to the battery to overcompensate the effect of the lowest temperatures.
All right, very good. I see this is a question coming in for Marco. Let's see, for a system where there are two different types of loads connected, and load 1 needs 4 days of autonomy, and load 2 needs 2 days of autonomy. Do you have any solution for this kind of requirement?
Yes, we can have a solution. The first solution could be offering two different batteries. The capacity can be split in the capacity for load 1 to offer 4 days of battery autonomy, and for load 2 offering 2 days of battery autonomy. Or maybe if the client is willing, of course, to accept a larger system, we can offer just a battery which offers 4 days of battery autonomy, which incorporates inside of the 2 days for the other load.
All right, very good. And here's a question coming in about temperature compensation. All right, so for an oil and gas application, if we are not able to use the standard RTS provided by the Morningstar for battery compensation purpose, what is the best RTS that would comply with oil and gas applications? So I guess I would probably throw that out to Marco, and yeah, let's see if you've run into that situation before, or what you could advise Ahmad, who's asking that question.
Okay, it's a very particular question, that one, to be honest, and it's also a very good question. I like it very much. I don't have an answer straight away. Of course, if Hamad is so patient to wait for our answer, we can discuss internally, and we can provide the answer to be shared to all the attendees to the webinar, if it is acceptable, of course, because I don't have properly an answer right now for this question.
Okay, very good. We can take that offline. Let's see, what solutions do you have as a bird deterrent? Noel is asking that question, so I guess that again would be for Marco.
Yes, by the way, let me explain a little bit about the story regarding the JCE Energy. JCE Energy designed the first bird scaring device, that supplied with solar panels in Doha almost 20 years ago, which is still working. We usually cooperate with companies which are providing the bird scaring device, and we build up the solar power product to give power to this particular burst carrying device. They are different in the market. Basically, is a siren which switches on when it detects a bird flying where they don't need to fly. Very simple terms, of course. And if Hamad is interested, he can drop me an email and we can discuss.
All right, very good. And I see a question coming in about the Modbus port. So I guess this one would be for Brad. Let's see. Does the Modbus port in the charge controller offer data to the other controllers or RTU?
Okay. Generally, the products right now, they don't have a need to intercommunicate. They can be set for similar settings, and they will charge together in harmony in terms of all bringing the battery up together. And then as the battery reaches full charge, they'll drop out one by one. Generally, they're pulled as a device by something externally that could be a data gateway or type of network device or a PLC. So the way that they're typically connected is the PLC can be the polling device on a SCADA network. They can all be connected together on the same bus. Typically RS-45 would be used because it supports Modbus with multiple device IDs, and then all of them collectively could be the data can be requested from them and sent to the PLC, and then on up to any type of management system or database with the rest of the SCADA data. And we've typically seen a flow information or IO data in the database right alongside with solar module power output ratings, load consumption, and battery voltage data over time as well. So yeah, they don't necessarily talk to each other, but they can all talk on the same bus to another SCADA device, if that answers your question.
I think very good. Let's see, we have a question coming in for Marco. Let's see. Could you tell me in hot weather conditions, what type of solar modules will be best to use?
In hot weather conditions.
Right.
Okay, we have worked many times in hot weather conditions. We have used every time the monocrystalline solar panels, which are working very perfectly. Of course, needs to be said that at the higher temperatures, you need to oversize the solar panels because beyond generally 28 degrees, the solar panels derate their power. So you need to provide more power to overcompensate the higher temperatures.
All right, very good. Thanks for that question. Thanks for the answer. Let's see. Also, can you elaborate on the telemetry system and for what application? So I believe we can start off with Marco on that question.
So the telemetry system, for example, for the quarry has been used to detect lorries coming inside the quarry, charging with sand, gravel, or whatsoever, and going back again where they need to go. The telemetry system has been specifically programmed to read automatically the number of plate of the lorry and sending this automatically to the main office for invoicing, registration, etc. This was one of the examples of the telemetry system that we have produced.
Okay, very good. I think that takes care of everything. It looks like we took care of all the questions. So we'll just leave this slide up here for a little bit longer. It has the contact info for JCE Energy and Morningstar. Thanks for everyone who attended, and thanks Brad, and thanks Marco. Terrific presentation, and we had lots of good questions that came in. At this point, I'm going to close out the webinar, and there will be a survey that will come up with a couple of questions if you want to answer those couple of questions after this ends. Other than that, we'll close out the broadcast, and we'll see you next time. Thanks so much.
Okay, thank you
Thanks,
very
everyone.
much. Thanks.